Hi everyone! In case you're not convinced about my proof of sum over 1 over n squared, here's my buddy Max, who will present you a different proof. And I promise you that your joy will be maximized.
Wow, okay.
Hi everyone. So I'm going to find the sum of this series. But before, I want to connect the sum of the series to my previous videos when we were looking for the sum of this finite sum. And you know, for case when we take the squares of these numbers, I got this sum. And then you can ask yourself, okay, I don't want to take finite sum, I want to take infinite sum. But when you take infinite sum, you get plus infinity. So you're like, maybe you just was bored and decided to take reciprocals of this number. And then when you will take reciprocals of this number, this sum might be equal to some kind of finite number. So let's find out what kind of number is going to be on the right hand side. Before I'm going to present an actual proof, I need to tell a little bit background that I'm going to use. So we are going to deal with polynomials. And what is polynomial? Polynomial just, for example, 2x squared plus x plus 1. This is like this form. When you have finite sum, you have x in different powers, you have different coefficient. Yeah, so it's pretty easy. And you can write polynomial in general form in this way. So an, x to the power of n, etc. What kind of facts we know about polynomials? We know if a is a root of our polynomial, p of x, then what does it mean like a root? It means if we will plug in a instead of x, our polynomial is going to be equal to 0. Then x minus a divide p of x. Let me show you an example. So for example, let's have polynomial x squared plus 2x equal plus 1. And we know the root of this polynomial is negative 1. Why? Because if we will plug in p of negative 1, we will have 1 squared, negative 1 squared, minus 2 plus 1. So 1 plus 1 minus 2 equal to 0. Okay, this is a root. And actually, you know you can factor this polynomial, and when you will factor this polynomial, you will see that it's equal to x plus 1 squared. And you can see, according to this statement, that x minus 1, or in other words, x plus 1, actually divides this polynomial. Yeah. In other words, when you're talking about roots, you're saying there exists some polynomial q of x, such that you can represent p of x as x minus 8 times q of x. But in other words, in this case, our q of x is going to be equal to x plus 1. So this is my q of x. So in other words, you're saying if your polynomials have roots, you can factor your polynomial. And we need one more theorem. If we will take all our coefficients as a complex numbers, you're saying every polynomial over complex numbers has at least one root. In other words, if we have this polynomial, and this polynomial is going to be over complex numbers, it means every time we're going to factor this polynomial, and we will get this polynomial in this form. We can do some algebra and change it in a slightly different form. So the right hand side, we can rewrite this in this way. What does it mean? What I did? I take L1, L2, Ln out, and I change the sign 1 minus x, so I will get this. And actually you can see before this polynomial has n roots L1, L2 up to Ln, but also if I will write in this form, L1, L2, and Ln also going to be roots of these polynomials. Why? Because if I will plug in, instead of x, L1, I will have alpha 1 over alpha 1 is going to be equal to 1. I will have 1 minus 1 equal to 0. So this expression is going to be equal to 0. I need small remark. If we have a polynomial of nth power, then I can have at most n roots. Why? For example, if I have n plus 1 root, so in this case I have something else, for example x minus gamma, And then you can see on the right hand side your maximum power of x is going to be x to the power of n plus 1. But on left hand side your maximum power is x to the power of n. So it's impossible for polynomial to have more than n roots if the power of polynomial is n. So it was like first part that we need to know. Let me summarize. The main idea is that every polynomial we can factor in this form, and if the power of polynomial is n, it means we will have at most n factors. Okay, let me ask ourselves another question. We have sine x, and you can think about, is a sine x is polynomial? And you will put this question mark, and you actually saying no, it's a not polynomial. Why? And there is really easy and beautiful proof. For example, assume your sine x is a polynomial. Yeah? In this case, it means if it's polynomials, and for example, in this case, you can see your maximum power will be x to the power of n. It means your sine function has at most n roots. Why? Because like this polynomial is fine, they have finite factors. But it's not true. Why? Because when I have sine function, what is the root of sine function? It's 0, pi, 2 pi, 3 pi, and when I will reach n pi, plus 1, I will have more than n roots. So sine function isn't a polynomial. But from calculus 2 you know that you can represent sine x as a Taylor series. And what does it mean? It means like you can write sine as x minus x cubed over 1 times 2 times 3 plus x to the power of 5, 1 times 2 times 3 times 4 times 5 minus ta ta ta. In this case, you think your sine can be represented in terms of polynomial, but this polynomial is infinite. So you can write your sine x, and let's think about this. We have finite polynomial over here, and on the left hand side I have sum, and for this polynomial I have at most n roots, so I write right hand side as a product of x minus root. So let's do the same for sine function over here. What is our roots for sine function? The roots for sine function is, how I said, like is 0, pi, 2 pi, negative pi. So let's just write down this on the right hand side. I will have x minus pi, x plus pi, x minus 2 pi, x plus 2 pi, and etc. And you can see on the right hand side you represent sine x as a product of infinite factors, where inside you have x minus a root of sine function. Sine x in this form. I will write this down as x minus pi, x squared minus pi squared, x squared minus 4 pi squared, x squared minus 9 pi squared. Why did I get these terms? I got these terms from here. Here I use formula a minus b, a plus b is equal a squared minus b squared. So you can see x squared minus pi squared. Okay, and you're saying, what is next? How it relates to the, like this question mark? Let me rewrite this sum by using this approach. So you know, like if you have finite polynomial, you have x minus alpha 1, x minus alpha 2, and the same as saying when you take out like alpha 1, alpha 2, alpha n, you will get another factor b, and you have 1 minus x over alpha 1. So let me do the same for sine x. So what I'm going to do, next my step, I want to divide sine x by x. I will have sine x over x, and I will have and when I divide sine x by x, and I'm also using this approach to write this right hand side in this form, I will have 1 minus x squared over pi squared, 1 minus x squared over 4 pi squared. So, and I will put bet in the form. And here, I want to write sine x in the same form. So I will take just my sine x and divide by x. And you can see when I will divide by x, instead of x I will have 1. Instead of x cubed I will have x squared. Instead of x to the 5 I will have x to the 4th power. And I have this sign x over x. And I have this sign x over x. And what I want to do, I want to find the coefficient stands before x to the power of 2. So on the from here I can see my coefficient is equal to -1/6 times x squared. Let me find the same coefficient over here, what is going to be equal to. In this case, I will have, so the first one I will have -pi squared. Why? Because x squared pi times 1, 1, 1, 1 infinite many times. So I will have -1/pi squared plus I will have -1/-4 pi squared. Why? Because I will take this coefficient and multiply it by each one. -1/9 pi squared. Minus and etc. And right now, and this is going to be times x squared. And right now you can see, let's make a huge equal sign. Yeah, what we have? We have -1 pi over square minus -1/4 pi square minus 1/-4 9 pi square minus equals -1/6. So I mean, like, we have x squared, so the coefficients should be equal to each other. And then what I'm going to do, I'm going to make it positive, so I'll multiply both sides by -1, so we'll make it positive, 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 positive. And then let me erase something. I will erase this really cool theorem, unfortunately, and these facts. So I will multiply left and right hand side by pi squared. And when I will multiply, I will have 1 plus 1/4 plus 1 to the power of 9 plus pi square over 6. And what I got? I got 1/1 square plus 1/2 square plus 1/3 square plus equals to pi square over 6. And ta-da! I got this formula.
Wow.
This beta you can actually prove that is equal to 1. But at some point I skip this, and you can just maybe write down below the comments why this beta should be equal to 1.
Yeah, people are going to do it anyway, so
Yeah.
leave the beta is equal to 1 to the viewers.
Yeah.
Just
So good.
So sine of x over x goes to 1. As x goes to 1.
Oh my gosh, it's so cool. It's so yeah. Oh yeah. Okay, so guys, prove. And you can see the left hand side is going to 1. And the right hand side, each x going to 0. So all these terms are going to 1. And so if I will take the limit of the right hand side, I will have limit. Let's say this right hand side is going to be equal a of x, like this all terms. So a of x, when x is going to 0, and it's going to be equal to beta. Yeah? Over here. And then you see, these two limits should be equal. So limit of sine x over x equal to 1 should be equal to the limit of the right hand side. So from here, from these two facts, I got that beta equal to 1.
Aha.
Thank you to the player.
Woo. Nice.